So you asked to graph a square root. It's helpful to know what a square root looks like. We call that the parent function. The parent function looks like this. And you could also get that from plugging in values. So this is going to look just like the parent function, except we've done a few things. Subtracting 4 to x before you do anything, like before you square it in a function, before you take a square root of it, before you do anything, subtracting 4 means you actually make a horizontal shift of 4 spaces to the right. And that's kind of counterintuitive. We think subtract 4 would move us 4 spaces back. But instead of starting at the origin, like the parent function, we're moving 4 spaces, 1, 2, 3, 4, on the x-axis. So that's where we are right now. But we also have to use that -3. The -3 is on the outside of everything, so when you subtract the 3 after everything's said and done, that's a vertical shift. So that means from that 4 spaces up, 4 spaces to the right, I'm going to go 3 spaces down. And there's a rough sketch of our graph. Starts there. Probably the bigger piece for why you're here, though, is the domain and the range of a function. When you have a graph, it's easy to get the domain and the range, because domain is all the possible x values. So for my domain, I'm going to say inclusive, because I can have exactly this number. Inclusive starting on +4, and it goes to infinity. Because with the domain, you look to all the x values that are possible. You can't have any negative x values. You can have +4, +5, 6, 7, 8, 9, 10, and as you go off to infinity. The range of the function is if the domain is all the x variables, then the range would be all the y variables. The range of the function, we're going to say inclusive, and then you do just what you did with the domain. You start with how low the y values can go, and then tell me how high the y values can go. So the lowest this can go is at that -3 that we shifted down to. The highest this can go is actually infinity, because the function slows its growth, but eternally will always be increasing. If you want to get out y equals 1 billion, you can. It might be way over here. It might be way over here on the x-axis, but y equals 1 billion is still possible. So it never stops increasing. So our range starts on -3 on the y, and then it can go as high as you want, positive infinity.